So I'm going to be talking about graph analytics at scale for GEOINT. Graph analytics are simply any type of data analytic that is done on data that is stored in a graph data format or a graph representation. A graph is just another data structure like a tree or an array. Fundamentally, a graph represents a pairwise relationship between two objects. The key ingredients of all graphs are nodes and the edges that connect the nodes. The edges can either be directed, in which you're only allowed to traverse from one node to another along a particular direction of the edge, or they can be undirected, where it doesn't matter which direction you go from node to node. Classic examples of data that's well represented as a graph are data that can be represented as networks, like road networks or communication networks, internet networks, and web pages and their links. That's an example of a directed graph in social networks. So there are some fundamental algorithms or primitives upon which graph applications are built. The first one is search. And there are two types of search, breadth-first search and depth-first search. Search is basically where you start at one node in the graph and you're looking for another node that has some attributes that you're interested in. There's cutting and partitioning, where you take a large graph and you try to cut it into two smaller graphs. Usually you're trying to do that in a way such that the number of edges that you have to cut in order to make those two smaller graphs is a minimum. There's shortest path, which is just what it sounds like, where you start with one node in the graph and you're trying to find the shortest path to another node of interest. And then there's something called connected components. A graph is said to be strongly connected when you can get from a particular node in the graph to every other node in the graph and vice versa. And then there's something called PageRank, which is a famous algorithm invented by Google, and it's basically a measure of popularity. And then the classic example applications of graph analytics are social network analysis, the traveling salesman problem. If you're a shipping company and you want to move a package from point A to point B within the constraints of your shipping network at that time. Cyber analytics, you may be trying to find weak spots in your own network infrastructure or in an adversary's network structure, and pattern matching, which I'll talk about next. I'd like to talk about one example that's in the public domain with regard to a geospatial application of graph analytics. Before I get there, I just want to mention that the way that we characterize graphs in terms of their size is usually given by the number of nodes or the number of edges in a graph. And I'm ahead. So the geospatial application that I'd like to talk about, if the slide will change, there it goes. Yay. I didn't expect to be ahead. That's great. So you'd start with some geospatial imagery, could be optical, could be SAR, and then you're going to want to create labels for the different areas within the image. And by the way, this example that I'm talking about comes from a Sandia National Lab report in 2013, and I can give you the reference for that if you're interested. And what they did was use traditional machine learning techniques to label the different areas of the imagery, whether it's a forest or grass or trees or water or roads or whatnot. Today, we'd actually recommend that you use a deep learning technique to do that. That would be highly effective. But once you have those semantically labeled areas from your imagery, then you can create a graph where the nodes are simply the regions that you've identified in that machine learning step in that pipeline. And those regions could have attributes such as size and aspect ratio and so on. And then the edges are simply the geographic distance between those regions. And then you're in a good place to perform some analytics. And you can look for patterns that might identify things like schools or other things, where you identify a particular pattern of buildings and distances with respect to roads and so on. And finally, the last thing I want to say is that the traditional sort of big data and NoSQL architectures that people use a lot for other types of data analytics often don't scale well for graph analytics. Because in graph analytics, the data is inherently non-local. You have to be able to quickly traverse through the entire data set. And so GPUs, graphics processing engines, can actually be a game changer for graph analytics. In this particular slide just shows some performance data comparing one GPU versus many nodes of optimized Spark architecture. And there's a couple of new technologies coming out in 2016 called NVLink and 3D memory, which I think will enable GPUs to become almost a de facto platform for doing large-scale data analytics, the way GPUs are seen sort of enjoying that status in the area of deep learning today. So thanks a lot.